in the past, if you wanted to go to a scientific meeting and you said you were going to talk about consciousness, it used to be that you were laughed off the stage.
Yeah.
They wouldn't tolerate it.
Right.
We're coming to a point where we're over the past 20 to 30 years for people who are really deep in this. But now I think the general population is starting to realize quantum mechanics is the foundation of every bit of chemistry. Well, physics first, then chemistry, then biology. And we are made of atoms and molecules and DNA and cells, which means those quantum principles exist within us. Now, we used to say that quantum doesn't hold in a warm, wet environment like our body, but we're realizing that in our body, we have things like microtubules that sequester these quantum. Quantum just means teeny tiny units of measure, basically. Teeny, 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 tiny. So you kind of have to think like Ant-Man when you think quantum and shrink yourself down below the size of a hydrogen atom inside of you. What's going on? And in that place, there's even more teeny, 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 tinier that we are trying to figure out the math of, okay, what allows something that teeny, 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 tiny to interact with this field of energy or waves of an ocean that we all move through. And we evolved as beings from mitochondria and bacteria from the ocean to be able to perceive just what matters in this environment, in this simulation, in this, if you can think of the movie The Matrix. So my body, if I were, 2,000 years ago hunting and running from the lion and finding food for my kids, my body can't care about all that subatomic information. There's no, if I had to perceive, it would be like perceiving the data stream into your computer. You wouldn't be able to function. So we evolved only being able to see what was important for our mitochondria, our bodies, to decide, are we going to be stressed? Do we have to hunt and find food or run from a lion? Or are we going to, our mitochondria are going to make us energy so we can procreate and pass on our DNA? So those quantum things, I call them magic, they're happening inside of us and they're happening between us. We just don't perceive them. So we use bigger and bigger microscopes and bigger telescopes to try to study what is happening at that subatomic place between our atoms and that field, and our galaxy in that field. It's the same concept whether you're talking about outer space or teeny tiny particles. Infinitely big out there, infinitely small in here.
Yeah, and when people start talking about the universe and all of that, that's the totality of all the everything. And one of the interests of yours that I thought was curious, and I definitely want you to kind of extrapolate on this a little bit, black holes, because we learned about them in science class when we're younger, but I don't think people realize they have an importance in their life. Can you talk about them a little more?
Sure. Okay, so a black hole is a place that has such a gravitational pull. It has so much mass in such a tiny area. It pulls everything around it in. So if we start with the fact that we are circling, our solar system is circling a black hole. It's called Sagittarius A. It's in the middle of our galaxy, and we think that all galaxies have black holes. That won the Nobel Prize last year. And it won the Nobel Prize by two different researchers who are studying stars that circle it. So we know it's there. Einstein and people before him, but Einstein wrote math that predicted that we would find it. He didn't want to believe it, but his math said that we would find a supermassive black hole in the center of our galaxy and other galaxies. So in 2019, we got the first real picture of a black hole. Why does it look black? It looks black because any subatomic particles that are spinning around it and any light photons that exist around it fall in and get trapped. Meaning, in order to get out of the black hole, you would have to get an ejection velocity or a speed faster than the speed of light to get out of the black hole. So that's a piece of it. We also know that there are microscopic black holes going on around us. So for example, we know that when cosmic rays from high energy emissions in outer space hit our atmosphere, black holes are created. So a black hole is a place in space that can have any radius. So Einstein wrote this math in 1915, and then this guy named Schwarzschild came along, and he defined the radius of a black hole. And he said, we're going to find them that are super teeny tiny, the Planck scale or the quantum scale or the subatomic, smaller than an atom scale. And we're going to find them at scales billions of times the size of our sun. When you have a black hole, all of the information in that black hole, what they call degrees of freedom, or the angles, the information stays the same, whether it's super teeny tiny or whether it's super massive. So we know that we're looking for them at what I call a giant microscope called CERN, or the Center for European Nuclear Research. We're looking for that there. That's the biggest microscope that we have right now on Earth. And we're looking for information with the James Webb Telescope on black holes in outer space right now. More information.
Yeah, a lot of people that watch like The Big Bang Theory, Sheldon Cooper on that show is always talking about the CERN super collider. So.
If you've seen the movie Atom Project on Netflix, we have an Atom Project, and so I think it's helpful for people to watch these TV shows, because then their brains, even if you don't understand physics, your brain can understand, oh, we have an Atom Project, and that Atom Project, ATOM, not ADAM, but it's a play on words, the name of the show. We have one in Switzerland, on the border between Switzerland and France, and they are actually slamming atoms together to see what this field of energy or information that we can't quite perceive what's going on in that space.
Is that a physical block or a mental block, Courtney, that people can't see it? Because there are people that perceive things that are unseen by the naked eye, by the physical eye, but they see things in their mind's eye. Is it because people don't open up their mind's eye enough?
Well, I think there's a couple things. One, we have 5 senses, right? We have these 5 senses. So we evolved with five senses. Some birds, some insects have a larger perception of so the electromagnetic field is one quantum field. And some animals that exist on this planet can see a broader spectrum of the electromagnetic field. Like they can see infrared light. We only see the 7 colors of the rainbow. Some can see ultraviolet light, some can see infrared light. So we evolved with senses to take in information about our environment so that we could evolve, make babies, do all that stuff. Your mind is more powerful than you can even imagine. So is it possible for you to perceive more about this environment? Maybe, but that's totally dependent on how clean you are. Meaning understanding ketosis, autophagy, all the other things that you talk about. So I think that our brains are, I'm going to give you a couple examples.
Okay.
There's something in science called the Benzene Ring, where the electrons around the carbon in this ring share information. They share what's called a cloud of information, just like a cloud, like a internet cloud. They share information. And the scientist who discovered that realized it because he had a dream about I always mess up this word, but it's called Oryibus, the snake that's eating its tail. He dreamed about that and woke up in one of his clean states like you have in the middle of the night, but his focus was chemistry. And he realized, oh my gosh, this benzene ring is sharing information between the electrons around the whole carbon ring.
Yep.
So it goes back to what I was saying at the beginning. When you are clean and focused and you have a high level of knowledge of whatever it is that you are working on, that's intuition, but that's a download from somewhere.
Yeah.
That's a download from this quantum field. That's information that you're getting that it already exists in nature.
Yeah, and I can give you an example. A few years back, there was a total eclipse. You might remember that. It kind of went across the whole United States, and I was right in that strip where it got totally dark here. And I have backyard chickens, Courtney, and so as the eclipse was starting, it hadn't even fully gotten dark yet outside. As it was starting, my chickens started acting weird. I mean, making noises I had never heard. You could feel this groan from within that they sensed something was off
Right.
from the norm. And we think of chickens as stupid, but those chickens have a lot more of a sense about what was happening than even we did.
Right. Well, I mean, in science, we know that birds navigate based on electromagnetic radiation. We know dogs can find their way home based on electromagnetic radiation. We know that that even the plants entangle light to give us oxygen. So there's so much more going on that we perceive. And because of those things, when we started this conversation, I said the scientists don't want to talk about consciousness. And we have this separation of church and state. Because of those divisions, if you even want to talk about this stuff, until very recently, you were just kicked out of the conversation, when all roads lead to the singularity. So you asked about black holes, and the one thing that I didn't say is, once you spin around a black hole and you fall in, there is no time and no space in that place. So in this place that I keep referring to as a singularity, there is no time and there is no space. They are interchangeable. To me, that sounds a lot like what the Bible calls heaven. A lot like what the Bible calls heaven. So if we are looking in science right now for what they call the unified theory of everything.
Yeah.
So we know that Einstein told us that gravity is how a mass distorts the fabric of space-time to hold something close to it. That's why I always say the sun holds us in its hug or its embrace by gravity. That's called general relativity. And again, I use analogies. If there's physicists in here, I apologize. I use analogies so people can get a visual for what I'm saying. At the quantum scale, we don't quite understand exactly how that works. But at the quantum scale, we know that there is a transfer from energy to mass, E equals mc squared. So, and that also equals frequency. So when people say energy, frequency, vibration, what they're really saying is energy equals mass times the speed of light in a vacuum times the frequency of oscillation, or those things are equal, energy, frequency, vibration. So we know that there is some place that we are going to be able to study, and it's going to be at this giant microscope even more, what's going on with the interaction between the subatomic particles, or the quarks that make up our protons and neutrons in our atoms, and that field. And that's what we are like honing in on day after day after day. So the best unification theory, so Einstein died looking for what unifies general relativity, or how gravity works on this massive scale in outer space, and how does gravity work on this super teeny tiny quantum scale. That's what we're studying at CERN. And the best math that we have is something called M theory. And M theory says that there are bridges or membranes or brains or strings or little teeny tiny particles that we can't perceive that connect everything to everything. And they are vibrating